know the rows of Pascal's triangle. Now, if I'm doing to the 5th power, I'm going to use Pascal's triangle because I can write those first rows pretty easily. But there is a way to get those numbers on your calculator. Now, your book talks about n factorial, so there's a button on your calculator that says PRB. And when you open up that menu, it says NCR, NPR, and that exclamation point, which means factorial. Factorial just means, 5 factorial would be 5 times 4 times 3 times 2 times 1. And 0 factorial is 1, just like 1 to the 0 is 1. So the binomial coefficient can be written like this. That NR is the NCR on your calculator. I'm going to show you how to do it by hand, but we're just going to use our calculator, okay? So the N is the 10, and the R, so the N would be my power, and the 5 would be my position. So if you put that in your calculator, you will get the same number as if. So here's the formula that they gave us right here. Sorry. N factorial over R factorial and N minus R factorial. And that's what. So 10 factorial over R factorial, which is the 5, over 10 minus 5. So if I write this out, it's 10 all the way to 1, and then 5 to 1 and 5 to 1. Well, these cancel each other out. And then 10 over 5 is 2, 9 over 3 is 3, 8 over 4 is 2, and 6 over 2 is 3. And so when I multiply all this out, 2 times 3 times 2, don't forget the 7, I get 252. But like I said, if you put this in your calculator, you'll get 252. We're not going to do it this way with our calculators. We're going to do it this way. Now, the NCR, if you remember from SM2, is combinations, and the NPR is permutations. So we're using a probability button to get the binomial coefficients. Okay? So when you do 5, 2, you would do 5 NCR 2. Remember, the NCR button is in your probability menu on your calculator. So 5, 2, do it the long way, is 10 times 10. Or you could look at Pascal's triangle. Remember, Pascal's triangle was like this. So the 5 means the row that it's the 5th, the n equals 5 row, but the 2 means the second position. But remember, we start counting with 0 with Pascal's. We did n equals 0, 1. So this would be 5, 0. This would be 5, 1. This would be 5, 2. And this is 5, 3. And that's why these two are both the same. So whenever these two numbers add up to each other, they're going to be the same thing. So for example, 6, 2 would be the same as 6, 4. Or 7, 1 would be the same as 7, 6, because 1 and 6 add up to 7. But like I said, we're just going to use our calculator. But this part of your homework, you're just going to be typing it in like this. So 5, 0, you'd go 5 NCR 0. Which anytime you do the 0, it's 1. And anytime you do the 1, it's 5. And remember, 5, 0 and 5, 5 are the same. And 5, 1 and 5, 4 are the same. And then 5, 2 and 5, 3 are both the same. So you can do one of them and you get 10. But then we put in these minus and plus signs and we end up with 1 minus 1, negative 5 plus 5. And the answer to that one is 0. Or you can just look at the 5th row in Pascal's triangle. So this one is your homework. You can practice this one on your own and this one. And this is what the binomial theorem looks like in your book. This looks really confusing, but really all it is a plus b to the n is going from k equals 0 to n for your powers. See, we go n, n minus 1, n minus 2, down to a to the 0, which is not here because a to the 0 is 1. And then you start with the b at b to the 0, b to the 1, b squared, and end up at b to the n. And that's what this is saying here. The number in front here is just Pascal's triangle or the NCR button on your calculator. So it's the same rules. We start with Pascal's or the row or your calculator, and then we do the first term with, in this case, it was a to the n and go down to a to the 0. And then the second term is b. We start with b to the 0 and end up with b to the n. And then we multiply all these rows together. And this is the piece that we already looked at.